My name is Martin French. I'm an engineering science student, third year. I actually did PY in second year. And I'm in the robotics option. So if you guys are an EngSci, you want to hear about the robotics option, talk to me after the session. And I'll be going over sort of how to use Git, why you'd actually want to use it in the first place, and overall the sort of purpose and practical reasons, things and tips and tools and tricks and stuff like that. You get the idea, right? So just to make sure you guys are aware before you begin, make sure you have like Git Bash installed if you're on Windows. If you're on Linux, then I doubt you would have come to this this session. But if you don't have like Git, just install it and then make sure you have like Vim or some other text editor. If you're on Mac, try to run Git from the terminal, and then Mac will be like, hey, I see you're trying to use a developer tool. Would you like to install Xcode developer tools? So then install Xcode developer tools. If you don't already, make sure you create a GitHub account and or log into your GitHub account and have it, just be ready. And the third one is optional, prepare a text editor of your own, but we're starting right now, so it may not be the best idea. Just have Notepad ready or Notepad ready in the sense that you're able to open files with Notepad, and Vim or some other text editor. So Mac can also run Vim, by the way. So Git. On the agenda for today, I'll be discussing exactly why you would want to use source code management and the whole idea behind it. I'll show you how to sort of get Git set up initially and get the keys set up for GitHub in particular. I'll show you how to modify repositories, but first observe repositories. When you're starting a project, I'll tell you sort of what the best practices are. We'll also be talking about how to commit things to a repository and then send that up to your repository up in GitHub or some server somewhere else. Then I'll talk about merging, modifying files, and other helpful things like moving a commit back and resetting your repository and using the stash, and also concluding remarks. So let's start with the beginning. Why would we even want to use Git? Well, let's talk a bit about writing. Sorry, Dante has a question. Should my default editor be Vim or VS Code? Does it matter? No, it does not matter. You can use Vim or you can use VS Code. Right, so SCM, source code management. So this is the absolute state of the source code or the software game, essentially. The idea is that everybody uses source code management, and Git is one of the most popular tools for this purpose. Git is very effective for solo projects and mandatory effectively for team projects. The basic idea behind this is that you would want to have some way of keeping track of the versions of your development code. And if there's a way that you can branch off and develop, new versions of it and then come back into like the mainstream, that would be ideal. So that's what GitHub does effectively. It allows you to take a current working version of your code, make a branch, add some kind of feature, and then reintroduce that feature back into the mainstream after all of your testing and verification, just to make sure it works. So once we verified it works, now we have this new working version of your code that has this new feature available. So a bit about Git. Git was initially created by the Linux creator, or the Linux kernel creator, Linus Torvalds. That was back in 2005. Back then, they had some kind of proprietary agreement with, I believe it was Bitdefender or something along that name. One of the companies providing a sort of like it's a distribution control software that they were providing. So Linus needed a tool to handle large branching projects because lots of people were adding new things to the Linux kernels, creating patches or creating new features or improving upon previous code and making it more efficient. Now, the proprietary code distribution tool they were using was lacking, so Linus decided he'd build his own. He'd focus on a few main features, those being speed, simplicity of design, support for nonlinear development, and that's a big one. Having the code being fully distributed and being able to support Linux and other sizable projects. So Git is a tool that's enabling you to essentially develop on things that are massive. You can develop operating systems using Git, Actually, you can find the GitHub repository for Android just on GitHub right now if you wanted to. So if you want to make your own version of Android using like Google's base as a baseline, you could. And that's what some people did. Some people developed this version of Android called Lineage, and that uses the root like kernel functions from the available open source GitHub repository. So Git's a very important tool. And if you have skill in this, then like, you're more desirable as an employee, and, it's just good to have all around. So let's start with the first things of Git, essentially. I'm assuming by this point you actually have Git installed. And we're just going to essentially tell Git who we are. This beginning portion is just saying git config. So git config allows you to check on the various configurations set for all of your Git processes. In this case, what we're interested in is just checking out, let me minimize this just for a second, bring it over here. Okay. Checking out who we are. So we need to tell Git essentially, who are we as a person, and what's our username, and what is our email. So things like GitHub, and GitHub is different from Git. Git is literally just a tool on its own, but GitHub is a service provided by a company. Well, the company's called GitHub, where you can upload your repositories to and create repositories and so on. There's an alternative to GitHub called GitLab. And there's other services too. You can actually run your own version of GitLab as well. But yeah, all the technical details aside, we still just need to define who we are for Git. So we do git config global user.name, and then we specify who we are. So I already specified who I am. If I just type this in, it'll return my name. So, I'm Martin. If I decide, hey, Martin's not that cool of a name, well, it's a very cool name, I'll have you know, but perhaps I want to be called Marvin instead. It returns Marvin now. So you guys get the idea, right? Very simple. Same thing goes for the user.email. So my user.email is this. Please don't DDoS me. Don't send me any spam either. But yeah, the global -- global specifies that this is for your entire computer, or rather your entire user. So when you do this global, no matter what repo you clone, you'll be referred to as your global account. So Martin, or in my case, my uToronto email and my first name. If instead you just did not specify global, you actually need to be inside of a repository directory. So, oh no, that's not good. A repository directory, I'll show you that in a moment. So the first thing we're going to do after we set all that stuff up for Git is talk about SSH keys. So as I mentioned before, we have SSH, right? So SSH allows us to access remote computers and also copy files and things like that. In order to access these repositories and push up to the repositories, we're going to need to create a new key and use that to essentially access our GitHub account. So if we want to make a new key, we just type in SSH keygen, give that a shot. And here it's asking for where I want to specify this this key. So if I want to put this key inside my, well, in your case, just hit enter. Because when you hit enter, it'll just essentially be this default like SSH path, and you can use that directly. I already have a key there that's with a name, but in my case, what I'll do is I'll just specify a different key. So I'll do martin/.ssh and then /git workshop. So this will be the name of my private key and the extension of my public key. So we hit enter. We do not usually want a passphrase, but if you want to make your SSH key more protected and more safe, you can include one. Just enter again, you don't need a passphrase, and there. So what we can do now is we can cat this file. So we do, no, that's not what I wanted, this .ssh / what did I call it? Git workshop, git ws.pub. So it's important that you specify that this is the pub. Git, no. So git workshop is just the name of my key. So, and this is the actual public key part of the key. So on GitHub, what you want to do is you actually want to copy this, copy that, and then you go into GitHub. So here we are on GitHub, and we want to go into the settings. So once we're on the settings, we just go to SSH and GPG keys, and then we add a new SSH key. So we can add whatever title we want, you know. I don't want to keep this key for later. So I'll just keep that as my title so I know to destroy it later. And then we just paste the actual key in here. So this adds the key to GitHub. And I need to include my password. Okay. And yeah. So I've added the key and it allows me to read and write. So now I can copy or clone directories and also push up. Do we just press enter to get our key? So if you're on, so let me bring back up the terminal. So if you're on this stage right over here, where you're asked about the enter passphrase, just enter no passphrase and then hit enter again. And then you'll end up with this sort of graphic indicating what your key is representing, like represented in some kind of image. But yeah, and then you can just check to see if the key is available by either catting it out if you're on Mac or Linux. If you're on Windows, you'll need to open the file using your text editor. So you do like notepad, and then the path to the key. So if I want to use the full path, I do home martin .ssh, and then we do git workshop.pub. There. But I don't have notepad because I'm not on Windows. Instead of cat line, if I don't have git workshop. If you don't have the name, so if you didn't use this same name, just use whatever this gave you. So this is the path instead. The default for the key is just ID_RSA, and it's inside the .ssh folder, inside your home directory. Hopefully that makes sense. Hayden, do you have a question? I notice your mic is unmuted. Okay, well, I suppose he doesn't have a question, but we'll keep going. Right. So now I've added the key to my GitHub. Now I have access to read and write. Well, the read part doesn't really matter if your public key is, sorry, if your repository is public, anybody can download from your repository. The write part is what matters though, because the write part basically tells GitHub who you are through that configuration. So when you set your email, your name, and that stuff. Sorry, I just need to do something really quick. Hey, Sean, could you give Steven some privileges? Or maybe I'm the only person who can actually create breakout rooms. Steven, could you actually like message Dante like personally, and then we'll continue on. Right. So we have the Git key added and back onto the terminal. So next we're going to look at cloning. So this is what we call observing. The exact command for cloning is here, but let me show you where I got the actual URL for this. So let me go here and my account. So the repo that we're dealing with right now, in order to add the SSH key, I went to settings. Settings, and then it's right here, SSH, GPG, and then new SSH key. Okay, hopefully I'm not jumping around too much for everybody. Is everything okay? You guys like, is this a decent pace? You guys understanding what's going on? Or is this too quick? Okay, then I'll keep proceeding as such. So yeah, typically when you went onto GitHub, you'd just, you know, download this stuff as a zip file, right? Don't do that. That's bad because you don't actually get like Git access stuff. So instead, what you want to do is just copy this SSH URL, and you're going to use this in your clone command. So let's bring up terminal back up again. So here's terminal. So I'm going to clear. So Git. So we want to do a Git clone. We want to a local repository of the thing I'm working on. What we're going to do is call Git Clone, and then we're just going to paste in the URL. So the URL in this case is git@github.com, and then colon, the username of the repository owner, and then the actual project .git. Now, if you don't specify the directory in which this will be housed, it's just going to clone into a new directory called IEEE-Git-Workshop, like just the name of the repository again. Since I already have one locally, what I'll do instead is I will call this Git Workshop. And it's going to clone into Git Workshop. So we see that we have Git Workshop available. We'll go in and check out the file structure. So on your terminal, it might not actually tell you which branch you're in. For my interpreter, I have special plugins on my shell that tell me exactly which branch I'm in. So right now, I know I'm in main, but if I do git branch, I can see that the only branch here is main. Okay. So we can check out what's going on in the file, have a look around. So we see that there's two files here, one README and one Python file. So we see that this is example repo for the workshop, and we need to implement fizzbuzz. So we check out fizzbuzz, the file, not that, we check out. So we do vim fizzbuzz.py, check it out. And we see, okay, there's some comments, fizzbuzz. So the definition of fizzbuzz is for 1 to n, print the number. If the number is divisible by 3, print fizz. If the number is divisible by 5, print buzz. If it's divisible by both, print fizzbuzz. Okay, cool. So we have a function definition here. And well, let's see what happens when we actually call this function. So we do Python fizzbuzz. Huh. And it returns exaggerated swagger of a software developer. Interesting. That isn't fizzbuzz necessarily. So we're going to need to do some work on this repository. In order to modify this repository, it's best practice not to modify main directly. Yeah, it's best not to modify main directly. So just a real quick thing here. So Pat, you're having issues with your key, right? Make sure that whatever key you're trying to add is the public key. When SSH produces their keys, you get 2. So let me show you that real quick. So .ssh. So I'm checking out the SSH folder, and then here's all the names of my keys. So you get 1 and 2. So this is the private key. Never share your private key with anybody, because if they have your private key, they can impersonate you, they can steal your data, they can access your GitHub, they can do horrible things. Don't share this, not even with your friends. Don't trust your friends, don't trust anybody, don't even trust yourself, don't even look at that file. The public one, you can share with everybody, it doesn't matter. So yeah, share the public one with GitHub, and it'll be in this sort of format. It'll specify SSH, the encryption type, which is RSA in our case, the actual public key, and at the very end, it'll specify the user and the computer. So I call my computer Morty. Probably a nod to some kind of a very highly intellectual TV show that folks seem to enjoy, myself included. So hopefully that's clear, and make sure that your key is in that format. Even if you don't get the key down right now, it's perfectly fine because you can still clone the repository. You just can't make changes on the remote, but we'll get to that in a moment. So back to where I was at. We have an issue with our fizzbuzz program. Yeah, we have an issue with our fizzbuzz program. It doesn't actually do what we want it to do. It just prints out, a nonsensical statement from a game journalist. So what we're going to do now is we're going to change it. But before we change it, it's best practice if we move into a different branch. So remember how before I said git branch shows us the branches we have available? Well, there's only two, main and nothing else. What we want to do is we want to check out a new branch. What we do in this case is we do git checkout -b, and this new branch, I'm going to call it Martin. It's my branch. I mean, in some other cases, you might also include some more descriptive language like solution, because we're solving the FizzBuzz problem. But for right now, we could just call it Martin, simply because that's who I am and I'm working on this one branch. So we checked it, we created the branch and we checked it out. So now we're currently in my branch, Martin. We do git branch and check out the various branches available, and we see that there's two now. But the key thing to keep in mind here right now is that this branch is only local to me. It does not exist on GitHub yet. Right, so now we have our own branch and I can play inside of it and do whatever I want. I can modify the code, change things a little bit, and sort of check out what else is going on. So ls. So suppose that now we want to check out the state of our repository. So we do git status. So nothing's changed yet. There's nothing to commit and the working tree is clean. Now suppose for some reason on this branch, I decide to incorporate a new file. This file is like a CSV type file, right? So let's check out buzz.csv. And it's like fizz buzz in there. Now let's just suppose that this is some kind of data file. And we can see that it's been added to our status. So the creation of a new file has been there. But perhaps what we want to do instead is not include these data files, because CSV files can vary. They can be output files. They could represent different things. If instead we want to ignore this, GitHub allows you to do that by creating another type of file. This file is called a Dot Git Ignore file. Dot Git Ignore. So basically what happens here is that for each line, you can specify the file type using a sort of standard, I think it is like Unix specifier. What does the ignore file do? Yeah, I'll get to that in a second. So Unix specifier. So suppose that we want to ignore all CSV files, right? Because that data isn't useful between repositories. So now we have two file types. We have a git ignore file and nothing. Isn't that kind of peculiar? Before, when I did git status, right over here, this guy, it said that buzz was here. But now I've added a git ignore file, and now buzz is gone. So the basic idea behind this is that the .git ignore file actually allows you to ignore certain files from a repository. And by doing so, it's not tracked by Git. Git doesn't care about it. It's just basically saying that buzz CSV file, it's not a fundamental part of the repository, so we're not going to keep it around. Now, the cases in which you would actually do this is when you are sort of dealing with data files or output files or report files that sort of summarize your code's output, So it's not always the case that you actually want to keep the executable that your code produces, because it's often the case that that might just be specific to some hardware. In this case, we produce a CSV file, but we don't want to keep that around because it's not useful for other people. It's not integral to the code base. And so in order to add this Git file, or this .git ignore file, we do git add .git ignore. So what this does is it essentially acknowledges that a change has occurred by adding it onto the sort of timeline of the repo. And then it's staging it to be committed. So right now it's not committed. It's just sort of in a quasi state where the change has been acknowledged, but it just needs to be validated and finalized. Now the validation and finalization comes from the commit. So git commit -m. This is a shorthand version of the typical commit message, but it's usually good enough to do this. You usually want to keep these commits short and simple, usually action and what you did. So in this case, we added Git Ignore file. Yeah, that's good enough. So now we do another status, Git Status. So on branch, nothing to commit. So the changes occurred locally, and it's been committed to my branch locally. We will not be covering the desktop version of Git. It's not actually, so typically in actual like industry, they don't use like desktop versions of command line tools. It's, yeah, but yeah, that's just to answer Pat's question. So back onto this. So this has been committed to my branch, and we can check out the commit actually by typing git log. So there's some other stuff that I did on the main branch before. So there's some other commits here, but we can see that the latest commit that I had, which is add git ignore, is right here. Okay, that's cool. And it even has a commit hash. So suppose now that we wanted to create this repository on GitHub, so it's accessible there. In order to do that, we just do git push -u origin, and then the repository name. I actually do not remember the repository name, but fortunately it was inside my copied buffer. Or no, sorry, it's not the repository name that we need. It's the branch name. So my apologies, everybody, because origin already specifies the repository. So we just specify this is Martin's branch, right? So we do git push -u origin Martin. The U stands for upstream. We do that. Now it starts writing it up to GitHub, and it created a new branch from origin called Martin. Cool. If we actually go on to GitHub and check this out, we can refresh this and see recent pushes. We have 2 branches now. We have the default branch, which is main, and then we have Martin. Cool. We can even check out what Martin has, and we see the git ignore file, and we're ignoring CSVs. Beautiful. Gorgeous. Now, anybody else out in the world can download my repository or my branch specifically, modify it, and then, do stuff to it. But yeah, that's just the start of the iceberg. Let's talk a bit about merging. The first type of merging I'm going to show you is just using the GitHub interface online through a pull request. It's good practice to get somebody else to approve your PR and review your code before you or they merge it. And it's also very important for you to be descriptive and brief in your commit message and your merge message. So what did this actually add? What did it do? Things like that. And if possible, use templates for your commit message or PR messages. Once your branch has been merged, just make sure to get rid of it. So I'm going to head over here, and we're going to go over to pull requests. And we're going to make a new pull request. So we have Martin. And so we're going to create a pull request from Martin into main. And we see that here's the different changes. We added a file, and then we added this CSV to the git ignore. We create the pull request. Let me increase this. And we write a very descriptive, meaningful message about what exactly we did. Then we create the pull request. So yeah, now we can squash and merge, rebase, and stuff like that. So we can create a merge request or merge pull and stuff like that. So since I'm the only person who's actually in charge of this repository, I'm just going to squash and merge it myself. And I'm going to go with it. So this is just my review of the code, essentially. Added the git ignore. So the branch was useful as whatever was Good. As it added the ability to ignore redundant data files. All right, well, I'm just gonna ignore that error because, you know, I'm an engineer and I don't know how to spell. And it's merged. Okay, cool. So now we head back to our main repository and have a look. We see that the Git Ignore is now there. Beautiful. All right, cool. But if we do, so next up, we're gonna do git checkout main. Go back to our main branch and see what's up. If we do ls-a and check for the .git ignore file, it's not here. What we need to do in this case is do a git pull. So like I said before, your Git is local to your computer unless you do a push to origin or you do a pull. So if I do a pull here, that's basically me saying sync up with GitHub. And you'll see that it fast forwarded my repository and added the new commit. So hopefully that makes sense to you guys. If that's unclear, let me know. And I'm just going to see what else is on our timeline. So the next thing will be merging via GitHub, and merging from command line is the next thing. So yeah, once we have everything incorporated, we can probably get rid of the original branch that I had everything on. So Martin, you know, it's been merged. There's no reason to keep it around anymore on GitHub. Goodbye. And it's just good practice to do that, because if you leave the branch open, it could cause issues where it's just dangling forever and doesn't get changed, and it just looks bad essentially, and it's difficult to manage. So we did that. And next up, merging from command line. So in order to merge from command line, this is sort of the process you'd go through. We're going to want to create a new branch. The branch I'll make is git checkout -b. So the -b in this case means create a new branch. And we're going to call this foo, just something simple. So foo has been created. All right, cool. Now we're going to make an edit to foo. So let's check out the fizzbuzz file and do some modifications to it. I personally don't think that this statement is very correct for the fizzbuzz challenge. So instead, what I'll do is I'll replace it with fizzbuzz. I think that might solve the fizzbuzz issue if we do Python fizzbuzz. Oh yes, it says fizzbuzz. Perfect. Now we solved the fizzbuzz and fizzbuzz challenge, and now we've made some meaningful progress on our repo. Let's add the file. So we do git status to check out what's been changed. Okay, so that's been modified. Let's see exactly how we modified it again. We do a git diff on fizzbuzz. Oh, okay. So on this file, we diffed it, and we see that these lines have been swapped. Exaggerated swagger of a software developer has been replaced with fizzbuzz. Beautiful. Okay, now we just do the typical add fizzbuzz.py, and then we do a commit. So git commit -m solved fizzbuzz. Now we just need to push it up to GitHub if we want to do it that way. In this case, we're not going to push up to GitHub right away. Instead, we're going to try to merge it locally. Before I continue, I just wanted to answer Pat's question. So he asked, what is the difference between push and pull? So from the command line, pull essentially syncs up with the remote repository on GitHub, or whichever server you're running your Git service on. In our case, it's GitHub. Push says, I want to push up something to my repository on GitHub. Hopefully that makes sense. So push is making changes, pull is pulling down the changes. What is the MIT license that we see on GitHub, and what are the different kinds of licenses? So I'm an engineer and I'm not a lawyer. So the different licenses determine how you're able to actually use different repositories. I didn't look into many of the licenses and sort of limitations on them. It could be like some nice bedtime reading if you'd like, but it depends on how you use certain projects. Essentially, that's the main idea. It's just a bunch of legal stuff, because if you commercialize certain things, then some folks get in trouble or they get angry at you without, giving proper credit or something. Or yeah, but this is more practical on the actual getting stuff done side of software engineering. So you don't need to worry about licenses too much because you're not making anything commercial yet. So the question is, if we see an MIT license, can we use their code and make a few changes and use it as your own? Your discretion on how you use other people's code, licensed or not, is up to you. And I'll just leave it at that. You can do whatever you want, and yeah. Of course, do it ethically, and if you're going to make money out of it, just make sure that you check the license to make sure that if you make money out of it, you don't need to give any money or something like that, or you acknowledge them or something like that. Like all the licenses are different, so check it out in your own time. So where was I? Right, FizzBuzz. We added all this stuff. We have Git Status, and it's going to say nothing to commit because branch foo, we do git log, has now solved the FizzBuzz issue. We modified a Python file, and now it prints FizzBuzz like we wanted, right? Hypothetically. Sorry, just getting a call. Silence for now. Right. And now instead, we want to merge it onto our master, our main branch, essentially. Okay, so we do git branch and check out. So we see the branches again. You don't need to do this, but I'm just showing you the branches. Locally, I still have Martin, but we have foo and main. Okay, so we do git check out main. So we're up to date on main, and we're going to try to git merge foo. Hold on a second. Let me just verify this is the actual correct command. I am more used to doing rebases though. Merge master. Oh, I had it backwards. Okay. My apologies. So we're on main, and we want to merge our foo branch into master. So we need to go on to git check out foo. So we want to merge foo onto master. So from foo, we do git merge main. Already up to date. Oh, or maybe I didn't have it backwards. Git check out main. Git merge. So we're trying to merge foo onto master right now. So we're on master and we're merging foo onto it. Git merge foo. Okay, that worked. So basically what we did was we merged foo onto master, and fortunately for us, there was no merge conflicts. If there were merge conflicts, we would end up with a modified file where we need to specify what the differences are. In our case, we're lucky. There are no merge conflicts, and when we look at FizzBuzz, or we try to run FizzBuzz, it does, our hypothetically solved version of FizzBuzz. Cool. But remember that this is not actually on GitHub yet. So if we want to make this a permanent change on GitHub, it is a permanent change locally. We do git log. We can see that solved FizzBuzz has been added. Cool. We need to do a git push. So here, because this branch already exists remotely, we do not need to do git push -u origin branch name, because main's already there. So we just do git push. We do a push, and worked fine. Everything's good. Okay, so I was thinking about getting into the next section of this, but I'll finish merging first, and then what do you guys feel about a break after that? Just like a 5-minute break. Would that be okay? Or maybe 10. I'm not too sure. You guys have probably been sitting around all day because of classes anyway. Make sure to stretch and stuff. So yeah, I'll finish merging right now, and then we'll do a 10-minute break. Right, so merging continued. So suppose that for some reason, there are two repositories that, not two repositories, there are two branches you want to make, right? So, or not even you, but you and your friend, right? Git branch B, git check out B, Barney. Barney's like, yeah, you know what? I'm just going to start from here. I'm going to make my own little edit of fizzbuzz. And I'm getting tired of this implement me statement. I want it to be more descriptive. So what if I made it say, I specify what the input of this thing is. And that's the number of counts for this game of fizzbuzz. Okay, cool. So, I mean, Barney's change is just a comment in the file. And if you're familiar with Python, what you can do is you can check out the actual change. So we're going to do from fizzbuzz import fb. So right now we've imported the file, the file function anyway, the function fizzbuzz, right? If we do help fb, it'll specify what the comment is immediately below the function. So yeah, I mean, what Barney did was useful. Look, now we understand that what this actually means, what implement me means. Cool. Closing this. So that's cool. We have all that stuff there. And let's do a git status and see what changed. So we have fizzbuzz. We're going to add that. Git add fizzbuzz. We don't care about the PyCache. The PyCache is just garbage. So what I'm going to do is do a git ignore. I'm going to include underscore PyCache. Another thing we can add to the list. There we go. Git status. Cool. Git add dot git ignore. Right. So those two things have been added. And we just do a commit -m. Added description to FB. And Barney is done. But Fred. Oh, Fred. Fred is working at the same time as Barney. So Fred branches from main. Git checkout -b Fred. And when we look at fizzbuzz again, we see that it no longer has its descriptive, title anymore. But Fred's just like, you know what, this thing doesn't actually need any description, so I'm just going to get rid of it. And that'll be good. So git commit or git add fizzbuzz git commit -m. It's removed description from FB. So now that's been committed, and Fred goes to merge it to main. So we go check out main, of course, specifying git before that. Git checkout main. We do a git merge Fred, and yeah, no big deal. Next up, we try to, so Fred merged his stuff in already, but now Barney's coming back and he's like, okay, well, I'm done with my repository. So let's just do a quick git merge Barney and call it a day. Oh no, there's a merge conflict. So this is when you have commitment issues, but hopefully you're all laughing. I can't tell. I'm actually talking to a void right now. But basically, we check out fizzbuzz and we see the issue. So in Fred's repository, he removed the descriptor completely. He removed the comment. But in Barney's repository, he just changed the comment. So because these two things branched from the same point and they changed the same lines, you end up with certain merge conflicts because GitHub doesn't know what to do. It's like, okay, well, it's happened at the same time, so I don't know. So in this case, what you typically need to do is take care of the merge conflict and pick one of the differences in the code. So right now I'm going to pick Barney's because Barney's is more useful overall. So we do a git status and check out what's going on. Both modified fizzbuzz. Okay, so git add fizzbuzz, and then we do a git commit -m resolve merge conflicts. And yeah, that's it. So we do a git log. And then we see the different commits from Barney and, or rather from Fred initially. And then we see the resolution up here. So we have Barney. So we added the description. Fred removed it, but then we resolved the conflict over here. So those are all good and all local. So now we just do a git push to send it to GitHub, and then we're done. So are you guys okay with taking like a 5-minute break or 10-minute break right now? Yeah. Okay, cool. So I will resume shortly. Feel free to ask some questions. I will just be a second though. And after the break, we're just going to talk about modifying things and conclude it with other helpful things in conclusion. So yeah, present this, and I'll be right back. Okay, I am back. Sorry, folks, but we're not going to begin quite yet. I'll just answer a couple of questions, and then we'll start again at 7. Hold on a second. Math. 7:05. Yeah. Right. So Hayden, your question. Dot Git Ignore only applies to specific files we are working on, or for the branch or the merge. The Dot Git Ignore applies to the entire repository. Like the Dot Git Ignore is a file itself, right? So it's sort of, yeah, it's just a file itself. And if you modify it for a certain branch, it applies for that branch because it's modified. And it just tells Git which files not to track. So you can't add certain files basically, and you can't commit certain files. I don't know if that's a very satisfying answer, but I'll show you one thing that might provide a bit more insight. There's this thing called the standard Git Ignore files available. And basically what a lot of people do is they just add these standard files to the repository when they're starting, which is honestly a good idea. And then you can just comment out things that you want to keep, in which most of these are things you don't want to keep anyway, though. But yeah, it's file wide. It's repository wide, but yeah, it's just a file. Any other questions? So have you guys seen FizzBuzz before? Are you guys familiar with that, like, coding challenge? It's just, yeah, you've seen it before? Okay. It's just a bit of a meme, though. I'm not too sure. Apparently, it was like a child's game that you're supposed to play. I mean, it seems a lot more difficult if you're, well, it seems a lot more difficult if you're doing this to a human. But for a computer to do it, it's trivial, I'd imagine. Because keeping tracks of multiples of 3 and 5 while also counting up is difficult. For people, at least, or for me anyway. Okay. If there are any folks, like if you guys feel like we should just pick up anytime, let me know. Yeah, definitely. You played it before and it's harder the faster you go. Yeah, it's like, what is it? Tapping your head and rubbing your stomach? Multi-coordination problems? Like playing the piano, I guess, I don't know. It's popular in language classes, so people learn the numbers. That's fair. I wonder if there's like a FizzBuzz equivalent for Japanese. I've been trying to learn Japanese, but it's pretty difficult. UK accent? From me? I suppose I'd be the only person talking. No, I'm not from the UK. I spent some time in California, but that's about it. So, yeah, I used to do a lot of acting, I suppose. Maybe I'm just acting like a British person. But yeah, okay. By the way, I actually think that you guys could push up branches of your own to my repository. The only thing you can't do is actually merge pull requests. Okay. So weird fact, some Canadians have a slight British accent. It's called a Canadian dainty. It's going extinct. That's unfortunate. The going extinct part. So should we modify the standard Git Ignore file or create a new one just for changes we might want to ignore for our project? You can use this as a basis. This isn't like the end all be all. You can always just, add more files you want to ignore or remove some files that you want to keep. Good to know. Where does it come from? I'm assuming you're referring to is his statement? And then she gives an answer. It's from when Canadian settler descendants wanted to keep the British accent, but it shifted over time into its own accent. Interesting. Because your father has a Canadian dainty accent. That's pretty cool. Okay. 704. Right. So, back on topic. Oh, by the way, I'll also make the slides available at the end of the presentation for you guys. What we have now is just a quick little thing talking about modifications you want to make. So suppose that there was a modification that I did, right? So we're in main, we're working on stuff. There's nothing new, but we're working on stuff. So we make a new file, right? We do buzzer.py. I'll write some useful things here. Not that. Do like a print buzzword. Just to prove it works to you guys. Yeah, sure, why not? And then, so we find out that there's some issues with this. Maybe we can't pull. So if we do git pull, we have some kind of issue upstream because we're working on an older version of the branch. So let me actually, yeah, no, I'll simulate that in a different way. But suppose we can't. So instead, we can hide all of our changes by doing a git stash. So what Git Stash does is it forms this stack of modifications we've made onto our current position. No local changes. Oh, my bad. So git add buzzer. So we do a git stash. We haven't committed anything yet. And now we're back to our previous commit. So git status of main. The idea behind this is that suppose that you can't pull things down from master. There's some issue there. In that case, you can use a git stash to hide away some of your commits, pull down, and then reapply using a git pop. Git. Hold on a second. Git stash dash lists. Oh, my apologies. Git stash pop. So now it reapplies whatever we put onto the stash before, and we see buzzers back. Not you. Vim buzzer is here. Yeah, cool. Like I said before, I'll show you an example of where this would be actually useful real quick. So reset dash hard. So let's do git checkout head. You're in detached. Okay, so what I did right now is I went back one commit. So if we look at git log, I'm actually before I applied the merge, like the merge resolution. So I'm back at Fred's state. Now, if I modify this, vim buzzer.py, print. Let's just do a quick status. Git add buzzer.py. Git commit -m added buzzer. So right now I went to a previous commit, and suppose that there's something that changed, like on top, right? So somebody pushed a new version of the main, and then I tried to pull from main. Git pull. Oh, GitHub is a bit smart. So part of this is it created a detached branch that I'm working on, and they just call it this. I would actually need to do a git merge. Well, in any case, write out, and I'm done. That's not what I want to do. Oh, yeah, and then X. So I made the edits and stuff, and then yeah. Well, basically the idea is that when you have a situation where you can't git pull from a remote branch, essentially, then you can just do a git stash and then a git stash pop, and then reapply whatever changes you've made. That's the basic idea behind it. So some other helpful things. Let's get out of this degenerate state and head back onto something that feels a little bit more comfortable. We check out main. I'll pull just to make sure everything's up to date. Cool. Suppose that we made an edit somewhere. We have some new file. And yeah, that file is registered here, status. But perhaps that we realize that something about this file or something that we did is causing errors or causing our entire thing to break. Well, we can actually reset the entire repository by doing git reset -- hard. What this does is it removes all the new files that you've added and only keeps the files that are in the actual repository on the latest commit, so the most recent commit. And you'll see here now swag is, oh, excuse me, still here. This only applies if you add swag prior. Git reset hard. Yeah, so if you added swag and it's staged for commit, but then you change your mind, then if you do reset -- hard, it'll actually remove swag.txt completely. So you need to stage it. Basically, you need to have it added. But that's that's one thing. That's one situation. So whatever you have, maybe it's a bad file, and it's staged, or just getting ready for commit. If you don't want it to be committed anymore, just do a reset. And if you don't want to actually kill it, so instead we just have swag hanging out, right? And we know that it's not staged right now. We add swag.txt. We do a git status. We see that this is staged for a commit. Well, yeah, like the usage just says, we do a git reset. And now if we do git status, it's no longer staged for a commit. So hopefully that makes a bit of sense. The basic idea is that you can remove certain files from staging commits or staged commits if you want to sort of not include them, basically. Just remember that. It's useful because you could end up in cases where there are certain aspects of the files that you've changed that cause problems, but you don't want to include in the main code. Or there are certain things that you've done that you don't want to include in that particular commit, just to keep things organized. Once again, we have git log, which will tell you all the commits up to this point. And yeah, that's essentially like a rough overview of using Git. And the more you use it over time, the better you'll be at it, and the more you'll understand the nuances of it. But that's essentially it. So for concluding remarks, for whatever language you're using, make sure you use some kind of linter, because having standard language is very, very useful, especially if you're using things that aren't like Python, because Python is like pseudocode and it gives you a lot of things for free. Formatting is free, types are free. But even for Python, you should have a certain standard way of writing your code. So the typical standard is PEP 8, so use that. GitHub works by examining trailing white space on the end of lines. So if you have trailing white space on the end of lines, make sure you remove that as much as possible to make the merge is more consistent and more reliable. The typical practice you want to have for developing with Git is you want to have a master branch that is untouched and usually has your release version of the files, and a develop branch that you branch off of and then add features to, then modify, and ultimately merge back up to master when it is time to release a new version. And yeah, one final note, some repositories use other repositories, and those are called submodules. The straightforward thing is just say, just type in the command git submodule init and then git submodule update, and that'll install the modules and get them all up to date. That's essentially it for the GitHub workshop. I'll stick around for a couple of minutes just to answer any questions, but thank you all for attending, and I wish you all the best in whatever software project you're using Git for. I will go over the stash git command once again, sure. Any other questions? Okay, I'll get started right on that stash part. Okay, so for Git Stash, what I'm going to do is I'm going to actually, I'll modify this file on GitHub. So line 10. They fizzed up. Changes. Excuse me. So I modified the file on GitHub and then line 10. Okay, cool. So we're at main. We're going to go to line 10, fizz buzz. Line 10. Print. Concerned ape. Okay. We have Git status once again, just to illustrate. You don't need to use Git status all the time. Git add fizzbuzz.py. And then we do so somebody's asking about the recording. This workshop, yeah, the recording of the workshop will be posted on YouTube and the links will be sent out later. Right, so we have Git status. So we see it's been added. Do a Git commit because this is the only thing we want to add. We do update fizz buzz. Okay, cool. Now, let's check this out. So we do some modification to vim fizzbuzz.py. So maybe we don't want it to say concerned ape anymore. Maybe we want it to say something like Deltarune. Okay, git add fizzbuzz. So right now, we know that that line has been changed remotely. If we try to do a pull, so git pull, it should give me an error. Yeah, so here, enumerating objects, counting, and then boom, error. Local changes to this file will be overwritten by the merge. So please commit your changes or stash them before you merge. So right now I haven't committed anything. All I've done is I've just added it. So we do a git status. So this is a case where essentially you're like modifying files, right? And maybe one of the files you're modifying, you want to keep. So maybe there's a whole bunch of work you did in fizzbuzz, but they aren't merging correctly. So instead of actually worrying about like committing it first and merging, instead what you want to do is git stash this current group. So the reason why you'd want to use this is because maybe there has been some kind of major update in main or some, in the repository you're working on, but it's for a feature that's slightly different from yours. So the majority of the feature they changed is not actually going to affect the code you've written. And you don't want to get rid of the code you've written because you're going to get rid of all that work that you put into this thing. So we're just going to do a git stash. So we save the working directory somewhere. Okay, cool. And then we do a git pull. So we pull down the latest. In this case, there's a merge conflict. And then we check out the merge conflict. Of course, it's going to be the print statement because they're the same line. Let's keep the concerned ape. Because at the end of the day, it doesn't really matter because we're going to change both of them with the pop. Okay. So we add the modified file, git commit the file with an M of resolved merge conflict. And then we do a git push just to make it global or return it back onto GitHub. So it's been cleared up, but we still don't, whatever. We still have the git stash that we need to apply to this. So git stash, git, I just need to remember some part of the command stash. H. Well, we'll try this, git pop. Git stash. So we try to pop it off and apply whatever changes we had onto the current repository. We get another merge conflict, which is, not that big of a deal. They're not that scary. As long as we know the code, it's fine. So we have updated stream and stash changes. So we just pick whichever one we want to keep. And in my case, I want to keep Deltarune. So we do that. And we're good. We do a git add fizzbuzz, and then we do a git commit -m resolved merge conflicts, and we're done. Git push back up. So hopefully that's clear and makes sense. Yeah. Anybody else have any questions? Okay, then I suppose I'll leave it at that. Thank you all for attending. I wish you all the best in whatever software projects you're working on or whatever courses you have that involve software. And hopefully this has been a useful experience for you. Slides will be provided and a video will be provided as well. But if you do need a quick reference, I highly suggest using this reference site called LearnX, X in Y minutes. It is if you're very, what's the word? If you're very familiar with a single programming language, this is a good resource. So it actually just covers the syntax and usually what you want to do where, standard commands you'll be using, and sort of how to deal with all that stuff. So this is a good refresher and good resource if you just need something quick and easy. And it actually applies to different languages and programming and tools too. So this is a general repository for everything. And I've used it for C and C++, as you can see. And there's a whole bunch of other things here. You can even look at Python, stuff like that. So yeah, that's pretty much it. So thank you, everybody, and enjoy your winter semester.